Hello and welcome to the channel. This is a classic mathematical problem found in numerous books published in pre-computer era. However, I couldn't find any video about it. So let's fill the gap. Just in case, I remind you that factorial of a number is the product of integers starting with 1 and ending with the given number. Thus, 1 factorial is just 1, 2 factorial is 1 times 2, which is 2, 3 factorial is 1 times 2 times 3, which is 6, etc. Of course, x in our case must be a positive integer, while y actually can be negative. However, it can be easily seen that negative y satisfies the equation if and only if its opposite, positive y, satisfies the equation. Therefore, if we consider only positive values of y, we will still have a full picture. So, for simplicity, let's assume that both x and y are positive integers. To solve the equation, we test integers for x from 1 upward until we realize that all the solutions are obtained and stop the process. Now, I suggest you to pause the video and try to solve on your own. Let's create a table containing the solutions. First column contains values of x. The second column is for x factorial. The third column keeps the sum of factorials from 1 up to x. Let's name such a sum as sub x for short. And the final column contains the value of y, if exists. We start, of course, with x equal to 1. 1 factorial is 1. S sub 1 is also 1. 1 is 1 squared. So y equals 1 and we have a solution. Then we take 2 for x. To get 2 factorial, we multiply the previous factorial by x. 1 times 2 is 2. To find s sub 2, we add up the previous sum and x factorial. 1 plus 2 is 3, which is not a perfect square. So no solutions for x equals 2, and we move on to x equals 3. 2 times 3 is 6, 3 plus 6 is 9. Another full square, another value for y, hence another solution. X equals 4. It may appear as a never-ending story to someone. However, looking at the height of the table, you've certainly guessed that we are close to the completion. 6 times 4 is 24. 9 plus 24 is 33. No luck for x equals 4, but we have another chance. X equals 5. 24 times 5 is 120. 33 plus 120 is 153. No solution for x equals 5, and since the table is complete, we must draw the final line and stop. Of course, the table could be longer, but that would be useless. Why? We see that 5 factorial ends with 0. Therefore, it is divisible by 10. The following factorials, 6 factorial, 7 factorial, etc., are divisible by 5 factorial, which makes them also divisible by 10. Therefore, all the following factorials also end with 0. This means that the following sums, s sub 6, s sub 7, etc., end with the same digit as s sub 5, digit 3. Such a sum can be equal to y squared only if y ends with a digit whose square ends with 3. Is there a digit whose square ends with 3? There is no such digit, as number 3 doesn't appear among possible last digits of a perfect square. This means that all possible solutions are listed in the table and no other solutions can be expected. So we write the answer. X and y are equal to 1, or x and y are equal to 3. We see that in both solutions, x and y have same value. However, most probably, this is one of the rare cases of mere coincidence in mathematics. And this is, guess what? The end.